Hello and welcome. Have you ever stopped to think about the incredible science that's hiding in plain sight all around your home? In the kitchen, the laundry room, even in the first aid kit? Well, today, we're going to unlock some of those secrets. Let's dive right in. So, what do cakes, clean clothes, and broken bones have in common? Yeah, I know, it sounds like the start of a pretty weird riddle, doesn't it? But the answer isn't a punchline, it's chemistry. All three of these are connected by a really cool family of chemical compounds called salts. Stick with me, and I promise it'll all make sense. So here's our game plan. We're going on a quick scientific tour of the house. We'll kick things off in the kitchen, swing by the laundry room, and on the way, we're going to uncover some really surprising chemical tricks that are happening all around us. All right, first stop, a place we all know and love, the kitchen. And we're going to start with an unsung hero that I absolutely guarantee is sitting in your pantry as we speak. Meet good old baking soda. Now, its fancy scientific name is sodium hydrocarbonate. It's what chemists call a mild, non-corrosive basic salt. And those two little words right there, mild and basic, that's the secret to pretty much everything it can do. Okay, now here is where the magic really happens. When you heat up baking soda, like when you put a cake in the oven, it kicks off this chemical reaction. It breaks down into a couple of things, but the one we really care about, the key player for making our food delicious, is that last part, CO2, carbon dioxide gas. And that gas is everything. It gets trapped in the batter and forms millions and millions of tiny little bubbles. Those bubbles are exactly what make our cakes rise and will give our pakoras that light, spongy texture. It's literally chemistry you can eat. But baking soda is not a one-trick pony, not by a long shot. It's also a key ingredient in baking powder. And, if you have an upset stomach, it can act as an antacid to neutralize that excess acid. And believe it or not, it can even help put out fires. And check this out. This diagram shows exactly how that works. In a soda acid fire extinguisher, you mix the baking soda with an acid, and bam, you get a super fast reaction that produces a ton of carbon dioxide gas. That gas then rushes out and smothers the flames. How wild is that? The same thing that makes your cake fluffy can put out a fire. All right, let's keep this tour moving. We're leaving the kitchen now and heading over to the laundry room, where we're going to meet baking soda's bigger, more powerful cousin. So if you take that same baking soda and heat it, you get a new substance called sodium carbonate. Then, if you dissolve that in water and let it reform into crystals again, you get this, washing soda. And hey, notice all that H2O at the end of the formula? That's a little clue about something we're going to talk about in a minute, so just tuck that away. So what's the big deal with washing soda? Well, it's an industrial powerhouse. It's used to make glass, soap, paper, all sorts of things. But at home, it's a fantastic cleaning agent. And its real superpower is softening water. It helps remove minerals that make water hard, which lets your detergent work way more effectively. And speaking of powerful cleaners, let's look at another chemical you might find lurking under the sink. Bleaching powder. I mean, the name pretty much gives away its main job, right? It bleaches fabrics and paper. But honestly, its most vital role is in public health. This is the stuff that's used to disinfect drinking water, killing harmful germs and making it safe for all of us to drink. Okay, for this next section, I've got a question for you, a bit of a mind bender. When you look at a crystal, like just plain old table salt, it looks completely dry, right? But what if I told you that's not always true? What if some crystals are actually wet on the inside? Let's check out this classic experiment to see what I mean. We're taking some of these beautiful blue copper sulfate crystals, and we're just going to gently heat them in a test tube. So what do you think is going to happen? Okay, so first, that vibrant blue color just vanishes, leaving behind a plain white powder. At the same time, you start seeing these little water droplets forming on the cooler parts of the tube. Now, where did that water come from? It came from inside the supposedly dry crystals. And the coolest part? If you add a few drops of water back to that white powder, boom, the blue color comes right back. This hidden water actually has a scientific name. It's called the water of crystallization. And it's a fixed number of water molecules that are chemically locked right into the crystal structure. For our copper sulfate, every single unit has exactly 5 water molecules attached to it. That water is what gives the crystal its shape and its color. All right, for our final stop, let's take this idea of hidden water and apply it to something you might be familiar with if you've ever, unfortunately,
broken a bone.
Take a look at the chemical formula here for plaster of Paris. See that at the end? A half of an H2O molecule. Now wait a minute. How is that even possible? You can't have half a molecule of water. Or can you? Well, it's actually a clever bit of chemistry's shorthand. It doesn't mean the water molecule is literally chopped in half. What it really means is that one single water molecule is being shared between 2 units of the main compound, the calcium sulfate. And this unique sharing structure is the key to its magic. When you mix that plaster of Paris powder with water, it eagerly grabs those new water molecules, reforming its crystal structure into a hard, solid substance called gypsum. That chemical reaction is exactly what makes a medical cast set hard. And this rapid hardening property is incredibly useful. Of course, it's used for supporting fractured bones, but you also see it in making toys and molds, creating those ornate decorations on ceilings, and even just making a wall surface perfectly smooth before painting. So there you have it. From making a cake rise, to getting your clothes clean, all the way to mending a broken bone, we've seen how these simple, everyday salts use some pretty amazing chemistry to play huge roles in our daily lives. It just goes to show you, science isn't just something that happens in a lab. It's in every single cabinet in your home. So the next time you're baking or doing laundry, just take a second to wonder, what other chemical secrets are hiding in plain sight all around you? Thanks so much for joining me on this little tour.